and multi-language programming. He is deeply passionate about bridging the gap between industry and academia using AI assisted tools and modern software practices. Sir, thank you for accepting our invitation and sharing your valuable time and expertise with us today. Welcome once again, everyone. Have an insightful and wonderful session.
The session is now handed over to you, sir. Sir, is it audible, sir?
Oh, sorry. My mic was on. Okay. So you guys able to see my screen, right?
Yes, sir.
Okay. Yeah, let's start. Yeah. So good evening, everyone, and thank you for being here. Thank you for uh, giving me the session. It's a wonderful opportunity to present it to everyone. Yeah. So over the next 1 hour, we'll be seeing our goal will be like a very simple one to take the mystery out of the artificial intelligence. So you have all heard the words like ChatGPT, machine learning, AI, AGI, and you probably wondered how much it is real and how much it is hyped. So by end of today, you'll understand not just what these tools are. Yeah, is it too low? My voice? You guys able to hear me?
Yes, sir. The voice is audible.
Okay. I saw some text. People are saying voice is too low. You guys able to hear me now? Those who are texting, it's too low. Okay. Yeah. Thank you. Okay. So by the end of today, you'll understand not just what these tools are, but how they actually work under the hood. What's going inside? What's going on inside? So where they came from and what they um, actually mean for our daily tasks and day-to-day activities. So okay, we are going to start at the we are going to start right at the beginning with the very first attempts at AI decades ago, how it started, and we'll slowly build up step by step all the way to the cutting edge technology what we have currently. Um, if you can follow it as a good story, then you can follow this. It's not a mystery about anything like that. So let's begin on that. Okay, so here's the agenda today. Here's the path we'll travel together. We'll start in the early days of AI and the problem that stumped researchers for decades. Then we'll meet the single idea from 2017 that changed everything and made today's AI possible, what we have today. From there, we'll open up the large language models. Like currently, we have this ChatGPT and Claude and Gemini, and we'll see exactly how they work. We'll watch the AI graduate from simply talking and chatting to actually how it does everything, how it takes action as agents, what they say in that term. And finally, we'll look over the horizon at where this is all heading, including that much discussed idea of artificial general intelligence. So that's the next level of AI, or what they call it as AGI. Okay. So you can think of this as a story in three acts, like how we got here from decades ago, and how it's working currently, and where it's going, where it will go to the next level. So all those things we'll be covering. Um, Please stop me with questions at any point if you have any doubts. Okay, let's dive in. Yeah. So let's rewind some decades back to 1950s around, when the dream of thinking machines first took hold. So they wanted machines to think, right? So that earliest approach was very logical. If it's like very simple logic, if we want a computer to be smart, let's just teach it everything we know as rules, like if and then, correct? So that giant collections of handwritten if and then rules were there for the computer to know what to do if something is there, and then this should happen, something like this. For example, like a patient has a fever and a cough, then suggest these are the illnesses it will come. So if the email says you have won so much money, then it's not a proper one. It's probably a spam. So those kind of predictions they used to do at that time through just simple if and then conditions, right? Um, so these things will work for small problems, very small, tiny problems. This actually worked for that. But here's where it fell apart. Imagine trying to write rules to recognize something as simple as a cat in a photo. They cannot set rules for that. Like you can set, right, like a cat has fur, 4 legs, pointy ears. But what about a cat that's curled up and asleep? It will look like a pillow kind of, so it will not find. Or if the cat is seen from a behind, or a black cat in a shadow, or a cartoon cat, something like that. So those things you cannot say it properly. So you need a near infinite list, and you'd still miss cases where that is it will say it's not a cat. So the real world simply has too many exceptions to write down. So these systems were very brittle. So they broke the moment they met something unexpected. So only the known rules and things it will work, and they couldn't learn anything new on their own. So that was a problem at that time. So by the decades of around 1980s, so this disappointment was so deep they just stopped funding all this researches and related to that. In what we call the AI winters, really handwriting every rule was a dead end. So researchers asked a different question, and that question changed everything. So that's what we'll be seeing at next. That is what it's called, machine learning, right? Like many of you might be aware of that. So the new question was this: what if we don't tell the computer the rules at all? What if we just show it lots of examples and let the computer figure out the rules for itself? That was the idea. So that's the whole idea behind that machine learning. Okay, so let's go back to our cat example. Instead of describing what a cat is, like fur and all those things, we show the computer millions of photos which say this is a cat and this is not a cat. And gradually, on its own, it learns the pattern that make a cat, right? So patterns so subtle that no human could ever write them down. The engine that makes this possible is called the neural networks. So that's how they achieve layers of simple math, very loosely inspired by how our actual brain cells connect to each other. So based on that, they have developed that neural networks. So that it will make a guess, and we'll tell it whether it is right or wrong. So based on that, it will learn whether that is the correct answer. Then it will decide the parameters based on that, and it will change its internal settings to do better next time, and it will predict whether that's a cat or not, like that. So stack like this neural network is, this is one layer. So like that you stack many of these layers together, and you get what we call the deep learning. So for years this was just a fringe idea because we didn't have enough data or computing power at that time. So then came this breakthrough moment around 2012 when a deep network shattered the record in a famous image recognition contest. So that was the spark. It proved that with enough data and enough computing power, these systems work astonishingly well. Almost overnight, machines could recognize these images and understand speech nearly as well as we can understand. That was just there was just one thing they couldn't do that. That is the language thing. So that's the problem. We turn to next language. How to do that? That was another problem. That's the next step of this. That's the language problem. So how to make the computer understand the language? Why was language so hard for computers? Because unlike a photo, language unfolds over time, and meaning depends on context that can be far away. Like let's take the word bank. The bank was uh, steep and muddy versus I deposited my cash at the bank. Like the word is same, but the meaning it completely differs. Right? And the only but the computer cannot understand. So that's the only way to tell um, is from the words around it. Like from the muddy and from if it is muddy, then we can think of it as a river bank. If it is a cash, then it is a actual bank we use it. So that the best language models of that era with names like RNNs and LSTMs. They used to read a sentence the way you might read it through a very narrow stroke, like a child would read, like one word at a time, from left to right, one by one word, one word, one word. Okay? So that trying to hold everything in memory as they went. So and that created very two serious problems. First, they forget because one by one, if you go through a word, the once they reach a sentence end, that first word will be forgotten. So that was a problem, and the words at the beginning had faded away because of so they kept losing the thread. One by one, it will lose. So that memory was the issue. Then they were very slow. So there was not much hardware to train very big data and all this because each word had to wait for the one before it. So that it was very slowly happening. So these were the problems. So you couldn't do the work in parallel. So that parallel processing was not there at that time. It couldn't, and so this language AI was stuck on two fronts at once. So it couldn't hold enough context and it couldn't scale up. These are the main two issues. So for a few years, progress stalled right there. Language AI, they couldn't progress further from that. And then this in 2017, I think a single research paper blew that doors wide open. That paper is called Attention is All You Need. I can share you that paper at the end of this session if people are not aware of that. So we'll check that out. Yeah. So how did this happen? So this was a major turning point in AI, what we have currently. So how did we break through that wall? The answer arrived in 2017. This is a paper from Google uh, with a bold title, Attention is All You Need. It introduced a design. It's called Transformer. So that's, they call it as Transformer models. So this is a single best reason we are all here talking about AI today. The idea is very simple. Instead of reading a sentence one word at a time, which the previous models failed at, it was taking so much time and resource was less, and those things, those problems were solved with this. Instead of reading a sentence one word at a time, and straining to remember that like what came before and after and all those things, a transformer model looks at every word at once, and for each word it asks which of the other words actually matter to that particular word. So that focusing is what they called it as attention. So let's take a sentence like that. trophy didn't fit in the suitcase because it was too big. So in this line, if you see, um, it it was too big. So we can understand that it means that trophy, because we know we have trained like that. So but models cannot understand like that. So this transformer model was able to do that, because it was able to relate that it to the trophy. So that is the attention. It relates that what is the relation of that it with the trophy. So that was more related to it. So it was able to understand that. So is that no matter how far apart the words sit, this was able to do it because every word is related to each other. And this one idea fixed both problems at once. It finally captured the context because every word can see every other word, and it could scale it up because it reads all the words in parallel instead of one by one. That was the previous problem they were facing. So that's a breakthrough that made it possible to train on essentially the whole internet. Lots of data it was able to go through, and it was able to relate everything, and that's a breakthrough. So we have used this chat gpt everywhere, right? So next time when you open chat gpt, that remember that t, chat gpt is there, right? So that t literally means transformer. That's a GPT is generative pre-trained transformer. It's a transformer model. So that's why they named it as like GPT, Chat GPT. So Chat GPT, this all Chat GPT all built on this, based on this 2017 attention is all you need idea. This is a starting point of that. So which raises the obvious question: what happens when you feed this transformer models almost everything humanity has ever written? Everything you just feed it into that model lab. So that's where this our next topic will come. That's called LLM. That's what we are going to see next. LLM. What is an LLM? So let's answer the question. Take this transformer model design and the thing, and feed it an almost unimaginable amount of text: books, articles, websites, conversations, codings, a huge data of everything humanity has ever written. That's what you once you provide all to that transformer model. That's where we get this large language model. So it is getting trained on all these data. It's a That's what we call it as LLM. That large in LLM, it's not an exaggeration because these models have read more than any human could ever have read in thousands of lifetimes. So that much data it has read. That's the naming for that large language model. So here's the part that surprises people. For all this sophistication, what an LLM fundamentally does is it's very simple. It just predicts the next word. Correct. So that's it. It does nothing. It just predicts the next word. So let's say if I type the capital of Tamil Nadu is, you just leave it. You give it to the model. That model will confidently say it's Chennai because it has seen that pattern countless times. So it was able to relate to that, find that this will come next if the sentence is like this. So that's what it does. And similarly, it will continue the sentence again and again and again, and it will start predicting the next word, next word, next word. Like Chennai, Chennai has these many places, and Chennai is next to this. Like that, it will start predicting. It will create a whole sentence. It will create the next paragraph, a full paragraph about Chennai, then an essay about that, and you can create all those quiz about that. It'll keep doing that because it's just predicting the next word from it'll feel like magic, but it's just really very good at predicting the next words in an enormous scale. It can do large paragraph. It can write a whole book about any topic you have given. And by that, that's where that name comes from. GPT. What do you mean by that? That's a generative pre-trained transformer. That's where the T transformer, it got it from that 2017 paper, attention is all you need, that transformer model. So if so next, if predicting this next word is all it does, you might wonder how on earth does that produce something as capable as ChatGPT or Claude or any AI that can talk to us like that. Okay, so then let's open that up. Let's look inside the LLM, how it works. So, okay, so inside the LLM, um, here's the whole journey your question takes from the moment you hit enter to the answer that appears. Step one. So this step one is the model breaks your text. Whatever you give, the model will break your text into small pieces, into words. Like, what is your name? The what is your name? Everything, it will separate it out. That it calls as it is called as tokens too. Okay, roughly word chunks it is. They in models perspective, it is all tokens. Every word is a token. Every word, every space, every this dot or comma, everything is a token to it. Okay, each token is turned into a list of numbers. Obviously, computer only do math. It can understand only numbers, zeros and ones and all this. So, and remember, remarkably, this numbers capture meaning. So that words with similar meanings end up with similar numbers. That's how it can understand things. So next step is that heart of it. The numbers flow through dozens, sometimes 100 stacked layers, and every layer, that attention mechanism we just met, decides which words matter to which. Every layer will be doing that attention thing. It will relate each word to the other, and that is happening in a large scale. So this is where the real thinking happens. What is the next word is not next to that, and like that. Next step is that on the other end, the model produces a score for every possible next word. So like for every word, it will give a score to that. Like capital of this is it is Chennai, Madurai, or some whatever you give, it will give a score to it, and based on the score, it will provide the result. And so on. The next step is it picks any one, usually likely the word, but with a dash of randomness, which is exactly why it can be creative. So, and why you get a slightly different answer each time. Not every time you'll be getting the same answers. So that's they called it as a temperature for the model. Temperature is like how creative it can be. If you give a maximum temperature, it will give the exact answers. If you give a temperature around average, it will give you a creative answer. And next step is it adds that word to your sentence and loops the whole thing back to the start to choose the next word. So this is how that LLM works. So then it's start predicting the next word, next word, next word. So basically, it's like words become numbers. Numbers flow through layers. Attention decides what matters. It scores the next word, picks one, and repeats. That's a simple loop. This is what happening inside an LLM. Okay. Running on a model that has read the internet is what writes you a poem or a lesson plan, everything. So now, if you are curious what's actually happening inside those numbers, let me pull back the curtain one more level. And if math isn't your thing, don't worry, you can just enjoy the view. So this, let's see the math behind this LLM, what's happening. For those of you who like to peek under the hood, here's the actual machinery. And I promise it's only 4 ideas. First, since computers only do math, every word is turned into a list of numbers called a vector. And the wonderful thing is that meaning becomes geometry. So the numbers for Raja, that's king, minus a man plus woman lands you almost exactly on Rani, which is queen. So second, each layer of the network does something simple. It multiplies those numbers by a giant grid of weights and then bends the result. Okay, those weights are the billions of parameters you hear about, and you stack about hundreds of these layers. So this third one is the attention, the 2017 papers idea, captured in that one line. For every word, it scores how relevant every other word is and blends them accordingly. Okay? And fourth is the learning, how it learns. So the model guesses. We'll measure how wrong it was with something called a loss value. And then we nudge every single weight a tiny bit in the direction that reduces that error, and we repeat that trillions of times. So that genuinely the whole recipe: numbers multiplied, scored, and nudged at a colossal level. This is a very basic level. It's going on, it will be happening repeatedly multiple times. It will be a very big scale. It's happening for everything you ask. So that's the engine, right down to the arithmetic. This is the math level, but it still doesn't explain why some of the models like Claude and Gemini or ChatGPT will feel that difference between each model, and that comes down to how they are being trained. The training matters. That will see the next slide. Okay. So it turns out that engine is only half the story. That whatever the LLM, that's the engine. But how you train that matters. A model fresh out of that internet reading phase, we call this pre-training, is actually a bit of a mess because it will have a lot of data. It will be very brilliant. It knows all the answers, but it will have no manners. Like it will tell you something randomly. It will not be polite. Um, it will not know how to present that thing, any uh, math problems in a proper way. It will randomly give some random things. It will simply ramble out or just continue your sentence instead of answering your question. So it will not be proper. So turning that will be a very raw model. So turning that raw brain into a helpful assistant, right? That takes two more stages. That Okay, so this the second stage is the fine tuning, where we show it thousands of examples of good helpful answers, so it learns to actually respond to what you ask. And the third stage is the clever one. It's called reinforcement learning from the human feedback. Real people look at two of the model's answers and pick the better one over and over thousands of times. Okay? So the model gradually learns what humans actually prefer, answers that are helpful, honest, and harmless. And this is the secret to your question. Is ChatGPT, Claude, and Gemini all share that same basic transformer engine. Engine is same, but each company does this raising of the model, like training of the model, or in the terms of it is like called fine tuning the model and giving the feedback to it. That matters. That is done differently. That's why these models behave differently. And that's why they have different personalities, different strengths, different senses of what's appropriate. They are less like different machines and more like talented students who went to different schools, right? Now, as capable as they are far from perfect, right? So we know everything is giving perfect. And the next slide is one I'd ask everyone to take to heart. This is very important one, where it is going wrong. What LLMs get wrong. So this is a very important one. So if you see, this is the most important slide for anyone using these tools in education or any important professions. So let me be direct. Large language models, it will make mistakes, okay? And they make them with total confidence. They will not know what is right, what is wrong. It will directly tell you. and that's what they call it as hallucination of the model, because the model's whole job is to produce text that sounds right. It will sometimes invent a fact, a quotation, or even a academic citation that will look perfectly plausible and is completely false. You cannot believe in that. So it is not lying. It has no idea it is saying a wrong information. It's just predicting convincing sounding words on top of it. It is just predicting the next words, right? So each model has a knowledge cutoff, a date after which it simply hasn't read anything. So you have to keep training the model with the new facts and new data. Otherwise, it will be like out of dated model, and that perhaps the deepest point. For all its fluency, the model doesn't truly understand the way you and I do it. It's an extraordinary pattern matcher, not a conscious mind. So here is a uh, golden rule. I'll say it's like treat AI like a brilliant, fast, but occasionally unreliable intern. It can draft, brainstorm, and explain wonderfully, but you, the expert, must always check its work. You should always check what it's doing, how it is, what information it's giving, how valid it is. That validation and verification really matters, especially for anything that matters. Keep that in mind, and these tools become incredibly powerful. So far, we have talked about AI that talks, right? Any chat you ask, it will give. Only those things we are going on. So, but something bigger has been happening. AI has started to act, right? It's doing work. It's actual work it is doing. Let me show you that what I mean. That's what they call it as agents. Okay. From LLM, a large language model, transformer model, to which acts like whatever you ask, it will give you that info. It's just a talking thing. To an agent, agent is nothing but a model that does a task for you. So everything we have discussed so far has one limit. The model only talks. You type, it types back, and that's the end of it. On its own, it can't check today's news. It can't run a calculation or send an email. Those are all. Those needs some extra tools. So this agent breaks it out of that box. The idea is to give the language model three things. One is tools, where it can use the tools and do some particular tasks, like a web search, a calculator, or the ability to open a file, read it, write it, delete it. A memory of, or you give a memory to a model of what it's done so far, it will remember that. These are all tools it can use. Um, and then it runs in a simple loop you can see on the screen. It thinks about what to do next. It acts by using a tool. It observes the result, what it is giving, and then it decides the next step, around and around until the job is done. So the difference is profound. The chatbot gives you words, agent does the work, actual work it is doing. And here's my favorite example because it's happening right now. This very presentation was built by an AI agent. I gave it a goal, and it read my files, checked what software was installed, and it wrote the plan using tools in a loop exactly like this. So that shift from talking to actually doing, that is the biggest change happening in AI today. But it doesn't stop with a single agent working on its own. If a single agent is there, then obviously multiple agents can be there, right? Because the moment you have one assistant that can take action, an obvious question follows: what if you had several of them? Each one is a specialist on its own work, working together as a team. So that is exactly the idea we turn to next. It is none other than this agentic AI. So this once you have one agent that can take action, the natural next step is to have several of them work together, right? And that's what people mean by agentic AI. Think of it as the jump from a single capable assistant to a whole coordinated team. Imagine asking AI to build a 6-week course on a Western Ghats or some topic behind the scenes. A manager agent could split that job up. One agent will research about the latest resources, the another drafts the daily lessons, a third writes the quizzes, and a fourth checks everything for accuracy and reading level. Then hands you a finished draft to review. So this ladder on the screen is a useful way to see it. At the bottom, AI just makes suggestions like autocomplete, a step up. It answers when asked. That's a chatbot most people know. If you go higher still, it completes a whole task for you. That's a single agent. And near the top, it coordinates a team of agents with a very little supervision. Here's the crucial point for all of us. The higher you climb that ladder, the more capable the AI becomes, but also the more your judgment and oversight matter, not less. More autonomy means we need to watch more carefully, like not walk away from. So, where does this ladder ultimately lead? So, let's look over the horizon. This next slide. So let me give you a quick honest tour of what's emerging right now. It's not a science fiction, but things that already exist or are arriving fast. First, reasoning models, newer AI that passes to think through a problem step by step before answering, which makes it dramatically better at math, science, and logic. Second, truly multimodal AI, a single system that can see, hear, and speak. You can point your phone's camera at something and just talk to it. And third is the computer use AI that operates software by looking at the screen and clicking like a person. So it can use almost any program. And fourth is the robotics, putting this same AI brain into a physical body. So it starts to act in the real world, right? And the fifth, AI for science. And this one is no hype. AI has already cracked the structure of proteins in a way that's accelerating medicine. Work recognized with a Nobel Prize. The thread running through all of it is that AI is steadily gaining new senses and new abilities to think, to see, to act, and to discover. So, which brings us finally to the term what hangs over this whole conversation, this AGI. What is that? AGI. Artificial General Intelligence. Right? You've probably heard that term, AGI. So let's be clear about what it actually means because it's widely misunderstood. Everything we have today, however impressive, is narrow. It's brilliant at specific things. ChatGPT writes, another system folds proteins, a third place chess, but each is a specialist on its own level. AGI would be different. A single AI that can learn and perform and essentially do any intellectual task like a human being can do, very flexibly and across every domain. So that's what they called as AGI. And even beyond that sits the hypothetical idea of super intelligence, artificial super intelligence. And AI, it's very smarter than all of us combined, all of whole human things combined together. It's beyond that. It's on top of that. So now the honest answer to the question everyone asks: Are we close? Is that uh, nobody knows about that. The leading labs are openly aiming for it, but it's on the way. Some experts think it's years away, others say it's decades, and many believe today's approach alone won't get us there. There's no agreed definition and no single test, which is exactly why the topic is so noisy. So let me leave you with this. We are not there yet. Today's tools are powerful specialists, not general minds, but the direction of travel is unmistakable. And that's precisely why understanding this, really understanding it the way you now do, matters so much. So we should not fear about it or hype it, but to understand it clearly enough to prepare our generation for the world it's created. And that brings our big ideas full circle. We have seen that what AI is, how it actually works, and where it's heading. So now let's come down from the clouds and get practical, because the real question once you're back in your classroom is what you actually do with all of this. And it all begins with one simple skill: how you talk to these tools, right? So let's start there. How to use these tools. One of the main important thing to understand, like how to use this, is this prompt engineering. So here's a skill that changes everything, and it takes about 5 minutes to learn. The quality of what you get out depends enormously on how you ask the model what you want. So most people type something like write a quiz on photosynthesis, and they get something very generic. So what's it? What happens when we add four more ingredients to that? A role, some context to it, a clear task, and the format we want. You are a let's say you tell it your middle school biology teacher. You are giving a role to that model, and then create a 10 question multiple choice quiz on photosynthesis for some class 8 or class 7 students. That's like giving a clear task to it and include an answer key. So same topic, but now the answer is genuinely usable, because the recipe to remember is role, context, task, format, and when it helps, an example or two of what good looks like. And here's a mindset shift. Don't treat it like a search box where you get one shot. Treat it like a conversation with that eager intent. So you should give all this role clearly, clear task, and format what we want. So all these things should be clear. Um, if the first draft isn't right, just tell it what to change. Make it harder. Add a short answer section. Use simple words, and it revises instantly. That back and forth is where the magic is. But how you ask is only half of it. Right? What matters just as much is what you give to it. Work. So let me show you what I mean. So that's the next part. That's called context engineering. What you provide the model, so from that model can give you what you want from it. So we just saw how to ask, but there's a second deeper skill that often matters even more, and it has this name: context engineering. If prompt engineering is how you phrase the request, context engineering is about what you put in front of the model, what you want the model to know, that raw material it has to work with. So that's the shift. As these models got smarter, the bottleneck stopped being clever wording and became whether you have given the model the right context. That matters. So think about everything you could hand it over to the model. Clear instructions, a couple of examples of what looks like, your own source material, your syllabus, the student's actual draft, the conversation you have had so far, and for agents, live tools and data. Watch what that does. Grade this essay gives you a generic response, like just grade it. That is very generic question to ask, and it will give a generic response. But if you tell, here's the assignment, here's my syllabus, here are two A grade examples for that, and here's the student's draft. Give feedback aligned to my syllabus, gives you something genuinely useful, because the model finally has what a human grader would actually do. Based on that, it will understand, okay, this has been done in a particular way, and I can do that in a similar way. Like, so there's even a way to do this automatically, which will come to a little later. The rule to remember is blend: garbage context in, garbage out, great context in, great output. So you now know how to ask and what to feed it to the model. The obvious next question is which tool you can actually open to do all this. Let's survey those options. The tool landscape. So which of these tools should you actually use? The good news is they're all built on the same ideas we just discussed, so you really can't go wrong. These are the big four things. ChatGPT from OpenAI is one most people know. Super all-rounder and a great place to start. Claude from Anthropic, that's me. That's what I use in a regular basis. Is it's like very exceptionally strong at writing, very careful analysis, good for research kind of work, and working through long documents. It's a very big context it has. Gemini from Google is deeply tied to Google search and workspace, and it's excellent with images and videos. And Copilot from Microsoft, it's good with when you're working with Word or Excel, PowerPoint, all those Outlook, all those documents. So it makes you very already work. So my honest advice, if you ask, don't agonize over the choice. Pick the one that fits the ecosystem you already use, and notice that the free versions are good enough to start today. Open two of them side by side, ask the same question, and you will quickly find a favorite. But the big chat assistants aren't the only game in town. For certain jobs, specialized tools do it better. Okay, so here's a quick cheat sheet for that. Best tools for that job. The big chat assistants are wonderful generalists, but for some jobs, there are specialists that simply do it better. So here's a cheat sheet you can photograph for research and literature reviews. Tools like Perplexity, Elicit, and Consensus are built to search real sources and hand you citations. And the deep research modes in Chat GPT and Gemini will go off and compile a report for you for serious writing and papers. Claude is a strong choice because it handles long documents and careful prose. So with Grammarly or Paperpal to polish. When you want answers grounded in your own materials, Notebook LLM is the one. You give it your PDFs and it answers only from them with citations. For students and tutoring, a lot of purpose-built things are there for images and diagrams. These things, DALI, Adobe Firefly, for slides, Gamma, Canva, Copilot inside PowerPoint. So a lot of tools are there. You can go through it. This and one honest thing is this list, like it's not constant. This will be keep on changing every few months. And frankly, the big three do most of these jobs well enough to begin. So match the tool to the task, whatever you are doing. And beyond this big name assistant, there's a whole shelf of tools built specifically for educators. Let me show you those next. You don't have to live in a chat window. There's a purpose-built tool for almost every part of your week, and most of them have free tiers for planning and content. Tools like Magic School, Defect, uh, for working with your own materials. Notebook LM lets you upload all your syllabus, textbook chapters, research papers, and ask questions answered only from those documents. For visuals and slides, Canvas, Magic Tools, all those tools are there. My suggestion is like don't try all of these. Pick one of that solves your biggest weekly headache and get good at it. Because if you start going through all the tools again, you'll be confused what to pick and what to work with. So just pick one and just see if it is good for you and just start using it. And we want to discuss one more important topic when it comes to this LLMs and models. So this is a thing, RAG and fine tuning. It's like giving an extra knowledge to the existing models, how to do that. So as you get more comfortable, you'll get this natural wish. I want the AI to know my material, my course, my school's policies, or my documents, not just the general internet. So there are two ways to do this. One is this RAG. It's worth knowing the difference. Most of the time we'll be using this RAG only. Mostly, it's RAG expansion is retrieval augmented generation. If you remember context engineering from earlier, feeding the model the right material. RAG is simply that. Okay. So think of it as giving the AI an open book exam. So when you ask a question, it first looks things up in the documents you gave and then answers from those. So often with So you can check notebook LM, which I mentioned right earlier. That is, it's based on a RAG only. It is cheap. It needs no special training, and because AI is reading from your real documents, it dramatically reduces those hallucinations, made up answers. It will not give any wrong answers to it. To you. The second way is the fine tuning. You actually retrain the model on lots of your own examples to change how it behaves, its tone, its style, a specialized skill for that model. Think of it as sending the model to a specialist school rather than handing it a reference book. It's powerful, but it's very expensive also because you need a lot of resources to train a model. It's not that easy to do it, and needs technical expertise also, like how to frame the training data for the models to train it. Actually, you cannot simply give a just a paragraph and you just train it. You need to prepare a set of training sets for that, and you have to provide the model to train it. That's a lot of data. That is very costly. It's very expensive, and it's a time tedious task. So the simple rule of thumb: if you want the AI to know your content, use RAG. RAG is a simple thing. It's RAG. If you ask, it's just a DB. It's if whatever the documents you have created, it'll simply create it as vectors, like what the models can understand, vectors of data, and those vectors are stored in a DB, and you give access to that DB. So models can and models have access to your documents as a DB knowledge. So from that, it can understand your documents and it can do well. So if you want to adopt a very specific behavior at scale, consider fine tuning. If for most of the things, RAG will be the best option for giving an extra knowledge to the existing models. Okay, so there's one more choice worth understanding, where the model itself runs, right? How it runs, where it is. Okay. Open source, there are different models. We have open source models, we have premium models. Where the premium models are this Chat GPT, Claude, and all those things. Premium subscription you are taking. On one side of the premium, and the closed models they call it as, and they're the most capable and the easiest to use because you just log in and then you just use it. You just chat with it and you give the task and you work with it. But then they run in a company's cloud. So whatever you're giving it as a text, it is being sent to the vendor. So they get the text. So they are having access to all your text, whatever you're asking and everything. And you're paying money for that. So on the other side are the open source models. So these, they have a names like Llama from Meta, and Mistral, and a lot of GPT models are also there as open source. They are free. They're completely free, and you can run it in your local machines. Those models are very small in size. For any basic task, you can use it. You can download it to your computer. You run it there. It just runs there. So your data goes nowhere. Whatever you're asking, it just stays in your system. Just running entirely on your laptop or any server, school server you started as well. So there are step behind the premium ones in raw capability, and they need some setup. But they have one
Dear
enormous advantage.
participant, mute your call.
Yeah. So okay. So this open source models. That's a one big advantage over premium models. Your data never leaves the building. It will stay in your laptop. But the premium models, whatever you are sending, it goes to their servers. So it goes out. Your data is gone. So if you are considering any student's data or your any personal data, you don't want to uh, give it outside. It's always better to use the local models for any simple task. It cannot perform any big task, but for a small task, it is very capable, and it is very important to know that it exists. Many of the people doesn't know there are open source models out there. So that's a full toolkit now. How to ask, we have come across all this, how to ask, what to feed it, which tool to open, and which kind of model to choose. Enough theory, the best way to believe any of this is to see it. So let me show you a few things you can try the moment you get back. These things, best way to so all these things you can try it out on your